Quick video showing how to get a sprite to move in a parabolic path, right, using an actual quadratic equation. So the first thing I'm going to do is establish, well, the first thing I'm going to do is create a sprite, which I already did, but all you would really be doing is uploading a sprite and some image from your computer, or you can choose one from the possible options that they have built in. All right, so what I'm going to do now is give my program a start. So when the green flag is clicked, I like to have it automatically go initially to a set location, all right, and default to that at the end of the program. So I'm going to have it go to this position because it's automatically encoded with the -197, 133, which is the position of the sprite. This is the sprite, by the way, currently. All right, so I also want it to go to that same location at the end, so I'll duplicate that and just kind of hang on to that. All right, I also need to define a variable because I need X's and Y's that are going to work for this program, but they're X's and Y's that would be different from the X's and Y's that are built in. So I'm going to run on down, all the way down to the bottom here where it says variables. I'm going to make a variable. First one I'm going to call X. For all sprites, okay. I'm going to uncheck it so that that little icon doesn't come up. And I'm going to create a Y, again for all sprites, and uncheck it. All right. So I have my sprite going to this location initially. What I want it to do then is start moving in that parabolic path, but I don't know the equation of that parabolic path. I know where I want it to begin, I know where I want it to end, but I don't know how I want it to move throughout the process, if you will. So what I'm going to do is I'm going to open a Desmos. And I'm going to type in the coordinates that I'm interested in having in terms of the movement of the sprite. So -197, 133. So I'm going to open a table. So I'm going to do that by clicking on the little plus sign. Table. -197, 133. All right. Then I'm going to kind of guesstimate where that vertex would be. Let's see, that's going to be about 2, -115. So 2, -115. And then I'll bring it back up onto the high side, so we're following that parabolic progression, and it'll come up somewhere around over here. All right, that's 183, 129. If I want it to be somewhat symmetrical, I can make it +193, 133, just to have that nice symmetry. It's pretty spot on to where I placed it anyway. So 193, 133. Oh, 197, 133 is what I meant to say. All right, so, and this should be a 197, but still, it's right it's in that neighborhood. All right, so you don't see anything on the Desmos graph, but if you zoom out a lot, it's -197. So, and we need it to go up to 133, and we need it to go down to -115. This is what we're looking at. All right, so if I want a parabola, I want it to go through this vertex. So I'm going to type in y equals, or f of x equals if you want, a, so I'm putting in an a value, x minus the h value is 2, squared minus 115. And then I'll have it add a slider for a just by hitting enter. So this parabola is not nearly wide enough, but if I start manipulating my a value, you see it gets wider and wider, but then it just kind of jumps. I want values between 0 and 1. That's how you get nice and wide. But once you hit 0, it goes horizontal and then starts moving in the other direction. If I go larger than 1, it starts getting narrower. So I want values between 0 and 1. So what I'll do is I'll click on this little -10. I'll make that a 0. And have it go to 1. And leave this open. And you see that the decimal values become a little bit more, I'll call it friendly. All right, but it still has that little jump going on there. All right, it's right around like 0.01 where it starts jumping. So what I'll do is I'll click on the upper bound, make that a 0.01. So now I'm living between 0 and 0.01, and it allows me to get even closer. Now, once you get to a point where you're pretty comfortable that you're going to hit both of those points, seems all right, then you'll have your equation. All right. So we're just trying to fit this parabola to the two points in addition to the vertex. All right. So it's a little asymmetrical, but that's okay. It's going to touch on both of the points really, and so now we have our equation. All right. So what we want to do is set my variable appropriately. All right. So we're going to set the x value. All right, we're going to set the x value to what it is initially, which is at -197, which you could just type right in. All right, so that's set now. We can pop that right on there. All right. Then what we want to do is we want to create a loop. It's a conditional loop, repeat until we hit a condition, and that condition would be when the x value gets to a +197, because the x value is starting at -197, and then it's going to work its way through the program until it gets to a +197, at which point it would stop. All right, but you see it has this little hexagonal open field here. That means that we have to use, where did it go? We could use, well, we don't want to use a sensor, but, oh yeah, there it is. We want to use an operator. All right. We want to use the equality operator. We want it to continue on until x gets to a +197. All right. So where's the x? We don't type in the x. We use the x variable. All right. So then what we're going to do is we're going to create our relationship. So we're going to set y to be equal to that equation that we just came up with. Y equals all of this. So this is what we got to type into that, but we got to be careful about how we do that on Scratch. All right. So we're going to go back to our operators. We're going to go for an equality. If you look at what we're up against here, and compare it to what we have in terms of our equalities here, I'm sorry, operators. Our operators are limited to the 4 functions, and then we have some other logic-based ones, and we also have some other special types of functions, exponentials, tangents, and so on. All right. So what we need to do is somehow get this into that block. All right. So we have our coefficient. It's going to be multiplied by a binomial squared, and then that's going to be subtracting a 1/15. So let's actually just start off with the subtracting part. All right. So, sorry, I grabbed the wrong thing. The subtracting part, because setting y to something is the same as equals. All right. 1/15. All right. So we got that last little bit here. We got this guy now. So now I need a product to give me a and these two. The binomial squared. So I'm going to tuck that in there. The a value is I believe 0.0064. Yep. Now this entry is going to be a product. All right. Now it's a product of a difference. So I need a product. And I need a couple of differences. the difference was, if I'm not mistaken, x minus 2, yeah. So x minus 2. So this x, not just typing in an x and a 2. We can duplicate that. So we have it twice. Pop it in there. So now it's 0.0064 times x minus 2 squared minus 115. And that's what y will be equivalent to. All right, so that's actually your quadratic equation. Now what we want to do is make some changes in our x value in order to create a movement in the y value. So what we'll do is we'll change the x value to go by ones. So it starts off at 197. It creates a y value based off of this expression, plots a point, or at least takes note of that point, and then increases the x value by 1. Asks, the program asks itself, have I reached 197 yet? No. Continue repeating the process of setting y equal to that new x value evaluated in this expression until you get a new point, and continue the process over and over again. All right. So what I would want to do is go to not 197, 133, but go to whatever the x value is followed by the y value as an ordered pair. So x, y. All right, so I would tuck this in between because I have the x value set at negative 197. I have my command to repeat until I get to a positive 197. I'm at negative 197, so I have to keep repeating the process. It computes a y value. It goes to that location. Then it increases the x value by 1. It checks to see if that new value is 197. No. Computes a y value, goes to that new location, adds 1 to the x value, checks to see if that's equal to a positive 197. No, so it keeps repeating over and over again until it gets to that x value of 197. All right, and then once it does that, I'm going to have it wait a couple of seconds. All right, because once it gets to 197, it'll have finished the program, but I don't want it to just jump right back to the end. I want it to take a second and breathe, so let me have it wait for 5 seconds before going back to start. All right, so this is the moment of truth. We'll run the program. So stressful. 1, 2, 3, 4, 5-ish. And there you go.